Hello, my name is Daniela. I am with Southern Oregon University in the Masters of Business Administration program, and this is my capstone project. This project focuses on business or organizational solutions. For my project, we will be exploring an organizational solution to clinical laboratory inventory management. For those who may not be familiar with the clinical laboratories are often present in hospitals, medical care clinics, and there are reference laboratories. These laboratories offer diagnostic testing to healthcare providers, hospital facilities, including emergency services and inpatient care, home health facilities, and outpatient clinics, such as family medicine practices. Within these clinical laboratories, diagnostic services are provided such as hematology evaluation, clinical chemistry diagnostics, microbiology evaluations, and transfusion services. These services provide analytical data that gives a unique profile to patients that describes their metabolic function, disease state, and assist healthcare providers in making clinical diagnostic decisions and providing treatment. To perform extensive patient diagnostic testing, many analyzers are used to complete these tasks. These analyzers use chemical reactions to determine levels of elements and compounds in the body, such as magnesium, potassium, red blood cells. For these chemical reactions to take place, specific reagents and products have to be present that support these reactions and maintain the analyzers for proper function. Reagent inventories are often analyzer specific and need to be readily available in the laboratories to support testing operations. This is where we will be focusing our attention today. The laboratory that we will be evaluating is based in Southern Oregon at the Providence Medford Medical Center, and this laboratory is a rapid response laboratory that provides patient diagnostic testing for emergency services, inpatient acute care, and stat testing for local outpatient services. Time and time again, inventory management practices prove to be at the center of many business practices and are often involved in process improvement initiatives, cost evaluations and reductions, and supplier selection and relations. Common inventory practices to optimize inventories include just-in-time, matching inventory to demand, using pull systems, reducing choice of features, and reducing multiple brands or suppliers, and adjustments of products to match the amount required for a particular process in order to reduce waste and carryover inventory. Now, companies and departments within the company must have a sound understanding of inventory management practices for the company to lead in production and market competition. Inventories are often difficult to evaluate due to the intangible cost nature that can make them difficult to measure. First and foremost, accurate data collection of available inventory, cost of supply, and forecasting of demand are critical to good inventory management. If any of these factors are miscalculated, a business may be harming their profitability. In the laboratory, this is critical because if miscalculated and stock outs occur, testing may cease, increasing costs due to sending to a third party when testing is not available in-house. Other inventory practices in the laboratory include ensuring that reagents are at their proper storage temperature and exposure. Some reagents and supplies may be sensitive to light, need to be frozen at room temperature, refrigerated, or have certain humidity requirements. And therefore, if not in proper storage, inventory ends up being wasted, increasing costs, and failing to follow good inventory practices. Healthcare inventory is uniquely different from other kinds of production inventory. Healthcare inventory is prone to hoarding, especially in the hospital setting. In the past, hospital inventory management has erred on the side of caution, maintaining inventories to supply the hospital for 3 to 6 months, if not for more than a year. More recently, with the improvement of supplier relations, supply chain practices, and technology innovations, new strategic inventory management practices have been developed across hospital systems. The barriers the laboratory in this case study face include the following. Mainly geographical location. Many suppliers such as Bedline, Thermo Fisher, and Siemens often have warehouses near larger cities. However, in Medford, there are no such warehouses. Each laboratory also contains different analyzers harboring different reagents. This laboratory does not share similar instruments with other local hospitals and clinics, making it near impossible to share our inventories. When back orders occur or unexpected events happen that increase our reagent usage, this lab's closest sister location is in Portland and Renton, Washington. Supplies and reagents are only able to get to this laboratory by air cargo and or courier services from these farther locations. The laboratory in this case study runs a cost center performance statement analysis each month. This analysis has a 3-month trending analysis, and it also has a year-to-date actual spending versus a target budget spending, and it gives us a variance analysis. Currently, we see that in September at this line 90 for our supply costs. In September, we are below our target costs. However, over here in our year-to-date, we're actually above our year-to-date cost by about $58,000, which is a above cost of 4.9%. For this study, this is the section that we will be focusing on. It is in the interest of this department to reduce this year-to-date actual versus target budget variance, and to reduce this variance to 0 or to get it up into a positive number. We don't want that number to be negative. So we have some project initiatives we wanted to do for this specific project. We want to create a reagent utilization audits for all of our technical reagents. We want to create tracking for monthly reagents that are wasted. Once that reagent waste cost is established, we want to reduce that waste cost by 10% on an annual basis. From the evaluation, we will give recommendations to the laboratory of what sustainable inventory practices need to be in place for monitoring reagent utilization and reducing the cost of wasted reagents. Our current inventory practices include inventory monitoring by all of our staff. We utilize a whiteboard to communicate reagents that are below our par levels at any given time. We also use Microsoft Teams to communicate urgent inventory needs. We also have a weekly electronic email communications to communicate supplier back orders or any stock out. Additionally, there is an inventory team of 4 who record and update inventory on a weekly basis, recording the amount on hand as well as updating supply expiration dates to match our current inventory expirations. About a year ago, the department updated their Excel inventory forms to calculate expiration dates and to alert when the reagent has an expiration date of less than 30 days. These cells in green are formatted to change to yellow when they are within that 30-day expiration. This allows the inventory team to ensure that these products are used first and to ensure products are ordered to mitigate stock out that could delay or limit our testing. During this case study, further formatting to this to order column was done so that these cells automatically calculate how many units of that reagent need to be ordered. And you can see that highlighted here in yellow. This is to decrease ordering above par levels and to reduce that hoarding that we talked about earlier of reagents past the demand of our patient testing. So currently we only have hard utilization numbers for just a few of our instruments. This is an example of our chemistry analyzer. On this analyzer, we are able to actually pull direct numbers of how much testing we are running each month for each analyte. The laboratory needs to establish utilization audits for all of our reagents. And this can be accomplished by running reports in the laboratory information system based off of our overall testing census. And we are also able to run reports that will tell us how much testing we are doing for each single test that we offer in the lab. This audit can be compared to ordering par levels to more closely allow the lab to set more specific par levels as they change throughout the year. For the month of October, we conducted an audit of supplies that were discarded due to being past expiration, meaning that they just remained on the shelf and had not been utilized in our testing, and this ultimately is leading to sunk costs. As you can see in the October audit, there were $2,000 of sunk costs of reagents. If projected on an annual basis, this results in sunk costs of about $25,000. This is a significant cost concern for the department, and this is what we are looking to address. Based on the monthly cost center performance statement and then our discard audit that we did, we had 5 significant case findings. First, the annual projected discard cost is estimated to be around $25,000. The year-to-date total supply cost as of September 2025 was $1,252,266. With those two numbers, the percent of estimated discard cost over that year-to-date supply cost was about 2%. The year-to-date actual supply cost was 4.9% over that target supply cost, with the discard cost being around 43% of that actual 4.9%. So what that means is, looking at this here, is that we're over $58,000 in our target budget essentially for year to date. And of that $58,000, 43% of that is actually going to be this annual projected discard cost. So that's a pretty significant percentage of how we're over budget. That 43%, again, is that sunk cost, and it could be avoided with our improved inventory strategy that we will go over next. Moving forward into strategic inventory management practices, it's recommended for this laboratory that in 2026, the goal should be to decrease that annual discard cost from that $25,000 to around $22,000. And this would be about a 10% reduction of cost. It's also recommended that this laboratory continues that discard waste audit monthly. This will help to determine trends in wasted reagents, help with the adjustment of par levels, and continue to evaluate costs of inventory. It would also be recommended that the department incorporates electronic inventory systems that allow for barcode scanning that uploads inventory counts directly into the electronic database. This may assist with any confusion over unit of measure numbers and reduce the data input errors, therefore making our inventory on hand more accurate. For these improvements to work, all laboratory staff needs to have ownership of this process. This ownership includes utilization of short-dated reagents to limit the discard waste cost and to follow communication channels for inventory needs. It will be the responsibility of the inventory team and management to educate and promote these initiatives with all staff. The final goal of this department should be to reduce that projected discard cost over that annual supply cost that we saw that was at that 2%. We want to reduce that to less than 1%. With all of this, the continued strategic inventory management practices in this department will allow for these recommendations to be a success for the department and ultimately to reduced overall supply costs. Thank you to the Providence Medford Medical Center clinical laboratory staff and management for their collaboration with the Southern Oregon University Masters of Business Administration program.